Okay, guys, so we are going back to trig. There's something that I wanted to do this lesson, which I haven't unfortunately had a chance to speak to you about just yet. So I don't know how far we'll get with general solutions. Like with everything in trig, it's just so vast and there's so much and so many different things that they could possibly ask us. It really is one of the sort of, I wouldn't say downfalls of CAPS. I mean, it's good that the syllabus is so thorough, but it also just makes it difficult for us as students to learn and understand every single possibility that they could potentially ask us. Okay, so you've seen before when we've done trig, when we've been speaking about Pythagoras or identity or ratio in terms of a letter or any of our general trig, we've always said that there are no calculators allowed. Now, for the first time, you are allowed to use a calculator in trig, okay, because you are going to be calculating the size of angles. So when we're solving equations and doing general solutions, we are solving for angles. It's like solving for x, but I think you guys know that already. Anyway, what I'm going to do is I'm going to start off by asking you a question, all right? What is a general solution? I mean, when you're doing trig and it says to you determine the general solution of whatever it is, what do they actually want you to do? What does a general solution mean to you? So just think about it if you want to share by talking or if you want to put something into the chat. What does a general solution mean to you? Okay, so Nhlanhla says to find a reference angle. Okay, that's part of it, Nhlanhla. That's part of a general solution. We should actually put these things down and just see. So Nhlanhla says, let me just, okay, so a part of it is to find a reference angle. Okay, so let's put that down. Okay, who else is going to add to this? Nhlanhla said we need to find a reference angle. Anybody else got something to add?
Let's go, my people. Let's be awake.
Yeah. Okay, I'll wait another minute just in case people do have something else they want to add.
Lebohang said something.
So Lebahang said to find quadrants the angles lie in. Okay, so working with the quadrants.
Let's remember to mute, right, my people? Either I'm trying to mute you, my friend, but I couldn't. But now I think I survived.
Okay, so both of you have said something that is relevant and valid, and it helps us in finding a general solution. Let's see what Sisipo says. A general solution is one where there is a range of angles that x could be in each quadrant. Okay, so we're getting closer. A range of solutions. You're right. You're getting closer. So in other words, what you're really trying to say, Sisipo, is that there could always be more than one solution. Okay. Amahle, you haven't missed anything. We are busy discussing what a general solution is. Today we're talking about equations and general solutions. So we are busy discussing what is a general solution. When we see a question in our general trig and they tell us to find a general solution, what are they actually asking us to do? And the reason why, and thank you so much for all of those responses, all of those are part of the answer. And I'm very, very grateful that you've said all those things because I can pull that into our discussion. But isn't it interesting, Matrix, how so often they ask us to do things in maths, all right? Find angles in an interval. Certainly, that's right on WABA. Okay, so there could be more than one solution based on a certain interval. Come pen, why are you not writing on a particular? Ugh, man. Let's just move this down. Okay, and let's just see, there was something else that someone said here. I just want to go back and go and have a look at what that was. Lebogang, values of x that can solve the equations. Yes, absolutely. So when we find a solution to x, the solution solves our equation. It makes the left-hand side equal to the right-hand side. Absolutely. But you know what's interesting, right? All of you have said things that are true, but no one has told me what a general solution actually is. And I think this is one of the most interesting things in maths, is because so often we ask you to do something and you don't really understand what the question is asking you for. What does it actually mean? Where does a general solution come from? Okay, and that's what I want to try and talk about today, at least for part of the lesson, before we get into solving general solutions, because I think if you understand what it means, your chances of being able to apply what you see to different situations is going to be so much better. Okay, so we're going to talk now about what a general solution is, and I'm going to use some diagrams, some graphs in order to be able to explain that. Before we do that, though, how do you know when you are supposed to find a general solution? How do you know when you're supposed to find a general solution? There are 3 conditions when we find general solutions. Does anybody know when that is? Any ideas? Okay, well, I'm going to give you the first one. Number 1, well, when you're asked to. Okay, when you're asked to. Okay, because sometimes they say to us, find a general solution, and that's when we're asked to. Amahle?
Good
When
evening, ma'am.
else? Good evening, Amahle.
Can I please add to your point?
Sure.
We do a general solution when we're asked to find a certain when we're asked to find a certain number of values, which are the angles on a Cartesian plane between 2 intervals.
Absolutely. Absolutely. So quite right. So let's say between negative 90 and 90, or between minus 180 and 360. So the idea is we need to do a general solution when they require us to find a solution to an equation where we are not working just between 0 and 360. So we are working outside, either smaller than 0 or greater than 360. Quite right. Well done. Okay, so when we have to find angles, smaller than 0 degrees, or why is this giving me problems tonight? Or greater than 360. So in other words, we are leaving the Cartesian plane. Is there any other situation? There is one more situation. You may not know this. Okay, so let's say they ask you to solve 4x, but they give you something like sine 2x equals 1/3. So in other words, the angle that they are asking you to solve for is not the same as the angle in the question. All right, then you also need to do a general solution. Okay, matrix, so there's 3 situations. Number 1, when you're asked to. Number 2, when you are solving for angles that are smaller than 0 or greater than 360. Or if the angle that they are asking you to solve for is different to the angle in the question, then you are going to find a general solution. Now, what you were telling me earlier about a general solution, yes, you have to find an RA or a reference angle or a positive acute angle, yes. You have to work in the quadrants, yes. There could be more than one solution based on a particular interval, yes, absolutely. A general solution is a statement. So, for example, let's say something like this. Theta is equal to 30 plus k times 360. K is an element of the integers. That is a general solution, right? So let's break it down into the relevant bits and pieces, okay? And the first thing that I want to talk about, okay, is what does this K mean? Why does every general solution have a plus K times 360 or plus K times 180? What does that bit mean for us? Amahle?
The K, it means the period of that function.
The K doesn't mean the period of the function exactly, but you're very, very close. It's not the period. The period, or how often the graph repeats itself, is the 360. So for example, if I have a sine graph or I have a cos graph, I would say that the period is 360 degrees, meaning that the graph repeats itself every 360. What does the K mean? No, it's not the values of the function. Interesting questions, hey, because we never really think about this. We just write it down because this is what our teacher showed us on the board and that's what we're supposed to do, and we just kind of get on with it, but we don't really understand what it is that we are doing. Okay, so I'm going to try this evening to pull all of this stuff together for you. All right, and I need to use a graph. Is it the values that satisfy the graph? No, Linda, you are very close. It's not the shift either. So shift would be either, if they said something like y equals sine x plus 30, then we are shifting the graph 30 degrees to the left, for example. Then that would be a shift. Okay, so let me explain to you what the K actually represents. And what I'm going to do, let me just see if I can scooch over here on the side. Okay, now those of you that did the boot camp class with me will recall that I was sort of starting to talk about stuff like this during boot camp, and a lot of you were like, getting closer, Leanne, good. How many times the period occurs? That's lovely. All right. So I just want to tie it back to what it was that I was saying. Okay, so just very quickly. We know that we can look at the Cartesian plane from one or two perspectives. So we can look at it like this, like a bird's eye view, where that's 0, this is 90, that's 180, this is 270, this is 360, right? We can look at it from that perspective. In which case, our terminal arm is anchored at the origin and it swings either in an anti-clockwise direction where angles are positive or in a clockwise direction when angles are negative, and it swings around the origin like the arm of a clock. Then we can change our perspective and we can look at the Cartesian plane like this, for example. So if I say to you, there is 90 degrees, there is 180 degrees, there is 270 degrees, and here is 360 degrees. Now I'm looking at it from the side, okay? So just like this is quadrant number 1, and this is quadrant number 2, and that's quadrant number 3. We all know this because it's quadrant number 4. So when we look at it from this new perspective, it's the same thing. Here is quadrant number 1. Here is quadrant number 2. Here is quadrant number 3. Sorry, I need a little thing. Here is quadrant number 4. Right? So when this terminal arm, the one that I have highlighted here in light blue, when it swings around and it comes back to the end over there, what I have essentially done is I have followed my pattern, my graph, through 360 degrees. So let's say I'm dealing with y equals sine x. Okay. This is what I've done. So up to 90, down to 180, there, and back to 360. So when this terminal arm has spun once in an anti-clockwise direction, I have essentially done this. Does that make sense to everybody? There we go. So see, what is the whole number value? You substitute exactly. All right. So now, in this case, if I have turned once in an anti-clockwise direction, that K value that I was referring to, I have done one revolution. If I now say that was one repeat of the cycle, if I say that K is equal to 2, then I would have to do 2 repetitions of the cycle, in which case I would need a whole bunch more space here, and I would have to go from 360 all the way down to 720. Does that make sense to everybody? Okay, so in other words, I've now gone like that. And now here, I've got to 720. So then K was equal to 2. All right. If I say that K is equal to -1, then in which direction am I spinning? Backwards. In the opposite direction, exactly. All right, so if K is equal to -1, I'm now changing the direction over here. Instead of me going in an anti-clockwise direction, now I'm going in a clockwise direction. Okay, that allows me to go back in this direction over here. Okay, so that's what K represents. K is an integer, and it tells you how many times the graph is going to repeat itself, either moving forwards from 0 getting bigger or from 0 getting smaller. Okay, so I know a lot of you're probably finding this difficult to understand. It's probably because this is the first time somebody has actually explained to you exactly what this means. That's why we say that K is an integer value, okay, because it can only swing in multiples of for example, it can only be a whole revolution or nothing at all. So either it can repeat itself once or twice or 3 times. The graph can't repeat itself 2.5 times, for example. Okay, Amahle, you've got a question.
Ma'am, so can you simply put it as K is the repetition of the graph as an easier way to understand it?
Absolutely. Absolutely.
Okay.
So K tells you how many times to either cycle forwards from 0 if K is positive, or K tells you how many times to cycle backwards from 0 if K is negative.
Okay, thank you so much.
And that's what allows you to find those solutions in a given interval. So for example, if you've got a general solution and you now need to find values between negative 360 and 0, you're going to have to use negative K values, aren't you? Because you are moving in the opposite direction from 0. You're not moving forwards where angles are positive. You're needing to go backwards. Does that make sense? So that is the function of the K. All right. So if you have a look here, oh, this is what I was playing with earlier. Let me just hang on a second. Get this into the middle of the screen. Sorry, I've had to go to a friend's house tonight because we've had no power at home for 2 days, and I'm sitting at a desk that I don't normally sit at, and I'm a little bit squashed. So I'm sorry, I'm just kind of jumping all over the
But
place.
so
But yeah.
nice. Okay, I don't even want to ask.
Yeah, no electricity again, as usual. Okay, right. So if you consider this blue, this is a sine graph, by the way. This orange graph is a sine graph, okay? And if you consider, we have been asked to solve the solution or solve for, let's write it in here, y equals sine x. And let's say, in this case, your y is a half. All right. When they ask us to solve for x, okay, this is where your reference angle comes in and the quadrants come in. So you look at the value of the half and you say to yourself, okay, that is a positive number, right? Which means that I need to find a solution working from quadrant 1 and quadrant 2, right? So then you find your RAA or PAA, in Tlantla, as you were saying, your RA, you all know this, by going shift sign, popping in the half, and out comes the 30, doesn't it? That's what this over here, this pink dot, that's what it represents. There's your 30. Okay, so if you look down here, there is 30 degrees. Now, if I am working between, let's say, negative 300 degrees up to, say, 600 degrees, there's going to be more than just one solution, right? So here's the first one. When you say that K is equal to 1, the cycle is repeating itself 360 degrees. All right. So in other words, you found the solution over here at 30. Then when the pattern repeats itself 360 degrees, where is the next one? It's going to be over there. Okay, so that is where you could say K was equal to 1. Okay, because that would allow you from your general solution to find the next value of x that satisfies that particular equation, which in this case would be whatever it is. Okay, if I now wanted to cycle backwards, all right, the next one, if k was equal to -1, I'd end up over here. And if I wanted to go even further back, okay, I would then end up over there, where k was equal to -2. So those integer values of k are what allows you to jump forwards or jump backwards on your graph to find the solutions in the interval that you are looking for. Right, now in this particular case, if we say that k is equal to, we've got sine x is equal to 1/2, we know that there's not just one solution, okay? Because we can also say, well, that's quadrant number 1. But in quadrant number 2, sine x is also positive. How would we find our angle in quadrant number 2? We would use our reduction formula, isn't it? We would say 180 minus our reference angle of 30, and we would end up with 150. There's 150. So now again, if you wanted to cycle forwards, there would be your next. Now this is k is equal to 1 here. Oh, why has that gone away? For that general solution. And again, you would be able to work backwards too. So if you wanted to go back to this one, you would have to say k equals -1. So in other words, RA is your reference angle, Unati. So whenever you're working with a general solution, you are finding a reference angle. So if our reference angle is 30, then based on the sign of our ratio, we would decide which quadrants we needed to work in. And then we could either solve for angles that are bigger by using positive k values, or angles that are smaller or negative by using negative k values. All right, so in other words, when you are working with a general solution, it is allowing you to work along the curve of the graph to find the solutions that you want. Okay, so this is why you actually learn about the graphs. And I think it's important to be able to tie what you do with the graphs together with your general solutions, because then you actually understand what it is that they want you to do. Okay, so just bear with me. Let's do one as an example, and hopefully all of this will become a little bit more clear to you. Yes, reference angle. Now, before we can find a reference angle in this particular case in Nhlanhla, there's something that we need to do. So we've been told to solve for theta if cos theta cos 24 plus sine theta sine 24 equals 0,715. What's the first thing that we would need to do there, Matrix? Have a look at your formula sheet that's here in front of you. What are you? There we go. Compound angle. Okay, so Amahle, what should I write on the left-hand side? So I've
Ma'am,
got
can you hear me?
Yes, I can hear you.
Okay, cool. So you'd say a cos bracket theta plus 24. I mean theta minus, sorry, theta
Good.
minus 24.
Lovely.
Mm-hmm.
Keep going.
And then you'd also apply is equal to 0,715.
Lovely. Well done, Amahle. That's great. Okay, so now the rest of you, I hope you understand what Amahle has done. Amahle has looked at this And she has said that is a compound angle. Cos, cos, sine, sine. So I know that it is a cosine compound angle. All right, so the one that I am looking at is this one over here. Let me just highlight this in pink for you. This is what we're looking at. Cos, cos, sine, sine, and there was a plus. That's why she has done the reversal of the expansion and she said cos A minus B. So in this case, cos theta minus 24 equals 0,715. Okay, so now this 0,715, this value here is an output. It is a Y value on your cos graph. That's what it represents. Okay. And they want to know how many angles between negative 90 and 90 have this output value of 0,715 on our graph. Okay. But before we can do that, we have to find our reference angle. So when we have got to a situation where we have the cos of an angle or the sine of an angle or the tan of an angle and it equals our ratio, that's when we do what you were saying in Tlantla and we find our RA or our PAA. So some teachers teach RA. At my school, for some reason, we call it a PAA, and that stands for a positive acute angle. Okay, but if you want to call it an RA, it's exactly the same thing. So now we're going to pick up our calculators. What are we going to press, guys? Can someone tell me what are we pressing on our calculators to get this RA? That's it. Well done. Shift cos. Pop in your ratio. And what RA are you getting? That's it. There we go. I quite agree. So 44,36 degrees. There we go. There is our RA. Okay. So now, based on the sign, not the SIN, but the sign, SIGN, based on the sign of our ratio is positive. In which two quadrants is cos theta positive? Good. Well done, everyone. 2 and 4. Good. So there's quadrant 1 and 4 you meant. There we go. 1 and 4. So there and there. So now we are going to do a general solution. Our first general solution is in quadrant number 1. And in quadrant 1, our general solution is our angle, which is theta minus 24, is equal to our PAA or our RA plus K times 360. K is an element of the integers. Now we have to collect like terms. And we end up with 68,36 plus K times 360. K is an element of the integers. So there is our one general solution. This is our one general solution. But there is another general solution that is possible with this ratio of 0,715, because the first quadrant is not the only quadrant where cos theta is positive. Cos theta is also positive in the fourth quadrant. So now we've got to say in quadrant 4, and you don't have to write the words quadrant there. I'm just doing this for you so that you understand where this is coming from. Our angle is theta minus 24, and it is equal to, in the fourth quadrant, our reduction formula is 360 minus our PAA or RA of 44,36 plus, sorry, move that out the way, plus K times 360. K is an element of the integers. And again, we need to collect our like terms together. Okay, don't round off to one decimal place or no decimal places. That's good. So it's 339,64. It must be two decimal places. Plus K times 360. K is an element of the integers. Okay, so there we go. There are our general solutions. Here's the first one. In quadrant 1, there's our first general solution. And here is our second general solution. Okay. So now again, I'm asking you, now that we've done this as an example, what does the letter K help us do? Why is it there? What is the purpose of the K? What is the purpose of the K being there? No, in Klantla, that's not correct. All right, because in the first quadrant, it's because then you'd have a different angle. Then you'd be working with the third angle of the triangle and not the one that we're dealing with. Okay, so no, you can't do that. Then you're working with a different PAA. So Linda, you always round your PAA off to two decimal places, because whatever you're going to be adding to it is always going to either, you or subtracting from it is always going to be a whole number. So it's not, your decimals are not going to change. So round it correctly to two decimal places in this bit over here when you get here. Okay. Exactly. All right. So in Tokoso, that's the whole point. That's the whole point of the K being there. All right. They have given us an interval between negative 90 and 90. They want us to find solutions for theta between those two intervals on the Cartesian plane. All right, and we have to use our general solution and integer values for k in order to be able to do that. So what Ntokozo is saying, she's not actually using the right word. Okay, that's the problem, Amatle. It's not a restriction, it's an interval. So what she's saying is what she's trying to say is that your solution is restricted to the values between -90 and 90, but it's not a restriction per se. It's an interval. It's a given interval. Does that make sense, Amahle? Okay. Now, often what teachers do at school is they then get you guys to create, I don't know if your teachers do this with you, but they then get you to create a table. Okay, so Gugu, what I was trying to say here is, and Ntokozo said, if there was a restriction, then we'd be able to substitute an integer value or integer so that the general solution falls within the given restriction. Ntokozo's words are not 100% correct, but I understand what it is that she is trying to say. What Ntokozo is trying to say is this, is that we have been told to find a solution for theta. Okay, there's our given interval over there, between -90 and 90. So the solution for theta, oh man, come now. Why's my pen doing this? The solution for theta has been restricted. Fair enough. Okay, we only want those values of theta that are bigger than -90 or smaller than 90. And we are going to use integer values of k in order to be able to do that. Okay, so what Linda was asking is it not a recommendation to round off your PAA value so you calculate your general solutions? I said yes. All right, so what you do when you calculate your PAA or your RA, which is this step over here, always round that to 2 decimal places. And then you will work with those 2 decimal places. Okay, because your decimal places are not going to change when you add 24 to 44.36. You're still going to have your 0.36. Okay, over here as well, can you see our decimal places didn't change when we said 360 minus? There's no decimals here, there's no decimals here. So it's fine to round it to 2 decimal places in the beginning when you find your PAA or your RA. All right, so now, essentially, this part can be done on the calculator. There we go. There we go. That's exactly it on WABA. Okay, so when k equals 1, you are cycling 360 degrees, if it's a sine graph or a cos graph, in a positive direction, all right, or anti-clockwise. When you do k equals 2, then you've done another cycle of 360 degrees in the same direction. If k is equal to -1, you've changed direction. Now you are going clockwise around the Cartesian plane, or you are moving to the left. I hope this is starting to make sense now. No, the reference angle is not an interval. This is the interval. 0 to between, so theta is an element from -90 to 90. That's your interval. That's your interval. That's not your reference angle. So we want to find solutions between -90 and 90 for these general solutions. So what is the reference angle significance? Okay, good point. Remember I said to you in the beginning, we go back here, all right? If you had sine x equals a half, you would then use the sine of whatever angle, and that ratio in order to calculate your reference angle. So this gives you your starting point on the Cartesian plane. Where are you starting? At what point along the curve are you starting? Where on the curve are you starting? It's your starting point. Does that make sense, Amahle? And then you are either going to jump in multiples of 360 going forwards or in multiples of 360 going backwards, depending where they want you to solve. Does that make more sense? There we go. Okay. So you find your RA as your starting point. Okay. All right. Hopefully this is all starting to come together for you guys and it makes a bit more sense. Okay, so we don't have a lot of time left. I just want to try and finish off this question if I possibly can. Can we see the cos graph? Okay, this graph over here, that is a sine graph. Do I have a cos graph here? No, I don't. Okay, give me 1 second. Let me get a cos graph for you. And then that would actually be very helpful, wouldn't it? Hold on 1 second. Let's get a cos graph. Just give me 1 second in lunch. I'm just going to get a cos graph for you. Okay, I'm almost there. Give me a second. All right. Oh, hang on a second. I didn't change the... Just give me 1 second, guys. I'll be with you now. I wonder if we maybe shouldn't make it even bigger than that. Let's go down to minus 720 and let's go up to 720. 720, and then you can see a lot of it. Okay, hang on 1 second. Here comes the graph. Go. Okay, so if you want to go and play around with these on the Cartesian plane, let's just get rid of that one. There's your cos graph. An excellent website is this one. It's free. It's called Desmos. Have you ever heard of it? Desmos. And if you look for the graphing calculator, it can draw literally any function for you that you can imagine. Okay. All right. So now, Nhlanhla, let's put this into context here. All right. So we've solved our equation. We've got 68.36. 68.36. So 68.36 is going to be, well, if that's 200, that would be 100. that would be 50. So I'm guessing it's going to be somewhere like over there on your graph. Okay. Now, if we wanted to go one cycle of 360 degrees forwards, okay, the next place that we would have our green dot would be over there. If we went backwards, okay, the next place that we would have our green dot would be somewhere over here. And again, if we went 360 degrees backwards in this direction over here, our green dot would be somewhere over there. Okay. So your K values allow you to go forwards and backwards. So when you say that K is equal to 1, it allows you to jump forwards by one multiple of 360 degrees from your starting point, or two multiples forwards, or three multiples forwards. If you say that K is equal to -1, then you're going backwards by 360 degrees and backwards by 360 degrees. Does that make sense to you? Jackson, I don't think there's going to be time for us to do that. Hang on, let me just take a screenshot of your question.
Can I do the poll while you take a screenshot?
Yeah, go for it.
Okay.
Okay, so just do the poll in the meantime. And then you've got this 339. Let's just do that in a different color. Yes, you can, Nhlanhla. You can if you want to. That's absolutely fine. Okay, that's just a different way of doing a general solution. It's going to be exactly the same thing. Okay, so remember originally, now they didn't give us much to work with here. They told us that our restriction was between -90 and 90. So that doesn't give us a lot of solutions because, I mean, after all, if this is 100 over here, the -90, I guess, is going to be somewhere over here. Okay, and +90 is going to be somewhere over here. So there's really only two solutions that we would be able to find. That one over there and that one over there. All right, so the green one, we'd find the green solutions using this general solution. And we would find the pink ones using that one. Okay, but they only wanted us to work between -90 and 90. So what would happen here is that we would have to let K be equal to 0. So if K was equal to 0, then our one solution for theta in this interval would be if theta was equal to 68,36 degrees. If K was equal to 1, then our angle is going to be bigger than 360, which means it's far bigger than that. all right? As far as this one over here is concerned, this 339, all right? Now we need to figure out what can we make k equal to so that our answer ends up somewhere between 90 and negative 90. So if we use 339.64, okay, that's okay. If it was equal to negative 1, here if we made k equal to negative 1, we could get another solution for theta, which would be negative 20,86. And then our solutions for theta lie within the domain that has been given to us. Okay. Yes, with pleasure, Onwaba. There you go. If you want to take a screenshot of that, you can try this question.